Okay, assalamualaikum and hello everyone. So today we are going to finish off chapter 3 with Faraday's constant. So we covered everything else. So today we're just going to cover these two. It's gonna be just a short video. So Faraday's law. What is Faraday's law? Before we go to what the hell is Faraday's law, we need to know that during electrolysis, okay, this whole electrical energy, using electrical energy to have chemical reactions, you will, during electrolysis, products will be formed at your electrodes, okay, your anode and cathode. And as electricity is passed through an electrolytic cell right here, okay, can our pass through electrolyte here, an amount of substance is produced at the electrode, okay, you will form products. So how do we know how much electricity, okay, or Q, is passed through our electrolytic cell, and how much of the substance that will be produced? So we will be using Faraday's law of electrolysis. It will describe the relationship between how much electricity that's passed through your electrolytic cell and the amount of substance that's produced. So your amount of substance can be in mass ke, mole ke, or whatever. Okay, so that's generally the Faraday's law, but we are specifically going to use Faraday's first law. So Faraday's first law, it relates the quantity of substance that's formed at your electrode. So M, quantity of substance, it is directly proportional to the quantity of electric charge supplied. So the more electric charge that you supply, then more product is formed. Okay, so this is the key, okay, the key to doing calculations to know how much product is formed. Okay, we are going to relate Q. Q will be your electric charge. So Q is equals to I where I is current in ampere and T is time. How much current is passed through and how long it is passed through, for how long. And that will equal to the number of electrons. Okay, kan during electrolysis, you will have redox reaction and you will know how many electrons that is involved. So Ne, it is the number of electrons, and F will be your Faraday's constant. So 1F is equal to 96500 coulomb. Okay, coulombs. So another thing you have to know is that 1 mole of electron is equal to 1 Faraday and is equal to 96500 coulomb. So if you pass through 2 electrons during your redox reaction, that means that it's 2 times 96500 lah. Okay, that's how much electric is applied. So it will be equal. So let's look at the first example here. Okay, so an aqueous solution of copper sulfate is electrolyzed using a current of 0.150 ampere. That will be your I. Okay, so you got the current and it is in ampere for 5 hours. So 5 hours, that means that's your time. Okay, so you can change that into seconds, right? So calculate the mass of copper deposited at cathode. Okay, so first we have to know the amount of electric charge. From the information that's given, we can know the amount of electric charge, or Q, that is supplied, okay, supplied to your in your electrolytic cell. So Q is equals to I times T. So your I is 0.150 ampere times with time. Time will be 5 hours. You change to seconds, right? And you will get your Q equals to 2700 coulomb supplied. Alright, so how much is how many moles of electron is 2700 coulomb? We know that Q is equals to IT, so this is how much electric is supplied. and it is equal to number of electron times F. So we want to know how many mass of copper that is deposited. So we can know this by doing stoichiometry. Okay, but before that we need to know how many electrons that is passed through your electrolytic cell. Okay, so from this 2700, you can find the number of electron that is passed through during this electrolysis reaction. Okay, so that means that 2700 coulomb is equals to number of electrons divided by 1 Faraday. Okay, so 1 Faraday is equals to berapa? 96500 coulombs. So from here we can find how many electrons is passed through. Okay, so this will be the mole, alright, any mole. Okay, so you will get 0.028 moles of electron. Alright, so 0.028 moles of electron is passed through during this reaction. So you know that you are going to discharge copper 2 plus, so that means that your copper 2 plus equals, okay, will be what? Will be reduced to form copper solid. Alright, so right here we, from this equation, okay, we are going to relate the mass, okay, the product form and electric charge using stoichiometry. Okay, so that means that in this reaction, okay, 2 moles of electrons will produce 1 mole of copper. Okay, so that means since we know that the mole of electron that is passed through in this reaction according to the electric charge that is applied to 700 coulomb is 0.028 moles of electron. So from there we can know how many moles of copper is produced. So you are going to use stoichiometry and you will get, ni kalau 2 dapat 1, that means that this value will divide, you will divide this by 2. Okay, so you will get 0.014 mole of copper. Okay, so now that we have the mole of copper, this is the amount of copper that is formed when 2700 coulomb of electric charge is passed through your electrolytic cell. Okay, when you electrolyze copper sulfate. Alright, so that means from there you can find the mass of copper deposited, right? So if the molar mass for copper is 63.5 gram per mole, you can find the mass of copper that is deposited. Okay, it will be equal to, mass equals to mole times molar mass. Okay, so molar what? 0.014 times with molar mass 63.5. So you will get your answer, which is 0.889 grams. Alright, so basically the key is for you to use this formula. Okay, so ni 2 ni, it is equal to the electric charge, okay, that is passed through. So ikutlah which information that you are given. Alright, so kalau nak cari the mass of copper deposited, mass of product that is deposited, that is produced, you are going to use, you need to find this part of your equation. Alright, so from, in order to relate these two, you need to use stoichiometry. Okay, stoichiometry from your balance equation lah. So from overall cell equation, you do stoichiometry and get mass of copper deposited. So when the electric charge is passed through, you know how much of copper is produced. Alright, so in this one, I'll buat lesson sendiri. Okay, is 2. Oh, banyak pula tiba. Okay. Alright, so end of 3.3, Faraday's constant. So macam biasa, try lah buat your tutorial questions, alright? Okay, bye. Thank you.